Hello everyone, my name is David Stevens, also known as Laser Dave. I am the Technical Development Manager for Trotec Laser. And today's seminar is titled Skills, Materials, and Laser Hacks to Help You Succeed in a Changing Business Environment. This seminar will use QR codes. If you're not familiar with QR codes, simply point your mobile device at the QR code with the camera on and a link will show up. This link can be accessed for videos, web links, as well as design files. Trotec is a very social company. If you would like to keep up with current events, applications, materials, products, please scan your favorite social media platform. We are on YouTube, Facebook, Instagram, LinkedIn, Pinterest, and Twitter. This course will include in-depth into laser processing wood, in-depth into laser processing acrylic, in-depth into laser processing glass, trending application and products, as well as a few new laser hacks, including HDR photography and compression joints using your laser system. Laser processing woods. Laser engraving wood offers a freedom of creating precise and personalized custom-made materials which add values to any business. Wood has a high perceived value and produces unique products. Custom-fit parts within the 1/10 of a millimeter, even smaller with delicate shapes. Save time and accommodate even the thinnest materials with non-contact processing. Wood is one of my favorite materials to laser process. It is very natural. The high perceived value that comes from wood makes it an outstanding material to process. However, there are a lot of different types of tips, tricks, applications, what to look out for, and details within this material category that I want to cover here in this course. Laser wood applications include the whole gamut, from architectural, toys, cabinetry, furniture, full photo engraving, signage, decor and gifts, holiday gifts, shop fitting, and so many more types of application. It is such a diverse material and works so well with laser technology that really the limit is only that of your imagination. I do want to cover some ins and outs and details of woods now to kind of identify what works best, what doesn't work best, and kind of what to look out for as you process wood with your laser. The first is choosing the right type of wood. As you can see, different types of wood can give different grain effects, different densities, different looks. And so we're going to go through some of the details of wood to kind of identify exactly the best benefits for the species and the type based on the application that is being processed. There are a lot of different types of species of wood out there. Hardwoods, softwood species, hardwood species, which tend to be heavy, more costly, darker in color, but however, they're naturally weather resistant and they last a lot longer, but they do have a high environmental impact. Softer woods tend to be lighter weight, they're more inexpensive, they tend to be lighter color, actually, which is an advantage on lasers, but they need to be treated for weather resistance, and they don't last quite as long. However, there is a less environmental impact when processing or using a lot of these different species. The big thing also with woods is kind of understanding wood density. Wood density has a big difference. You know, there's a lot of different wood species out there. For example, alder, balsa woods are very, very soft woods. And the softer the wood, the faster the laser processing. The harder the woods, the more impressive it tends to look, but the problem is that it's more expensive, and it can also take a lot longer to engrave, and it's much more difficult to cut. So we're going to get into a little bit about density so that you understand the vast variety of species of wood and when to use them and when not to use them based on the type of laser system that you have. Here's a nice chart with some of the more common woods. Soft woods such as balsa require less power and for engraving and cutting and can be completed more quickly. Hardwood is typically a dense material that will require more laser power. This chart kind of tells you some of the more common species such as balsa, cork, basswood into pine, spruce, then into oak and cherry, and as the density gets deeper and deeper, walnut, maple, ironwood, into even like ebony woods. These are some of the densest woods. Increased density of wood will require increased laser power. So that's the difference, especially in order to engrave this to the same depth as, say, a softwood. It takes considerably more power as the density of wood goes up. And that is a big difference on it. Now, is really kind of an understanding is how dark the wood is, how dense it is, and then to determine. Not all wood is going to work the same. And it's understandable that you may not understand what species is what. There are a lot of species out, and this next chart will tell you. This is a list on Wikipedia of the 320 common woods in this world. So it is understandable that most species are not truly understood, what they work. The benefit is all woods will work with lasers. Not all woods produce the best effect. Dark woods will produce a darkened engraving, which we'll get into. For example, light woods will produce a better engraving. But I do want to kind of explain. It is understandable why you may not have heard of a certain species, because there are so many to choose from. When laser processing wood, you typically get a dark cutting edge or brownish or whitish colored engravings. That can serve as an exceptional design element on wood products. The lighter the wood, the better the contrast. No additional time-consuming cleaning is typically required. A little bit of wipe down, which we will get into. But unlike other technologies, engraving can be achieved in the matter of seconds. You put the piece of wood into the machine, it'll engrave it, it will cut it, and you're done. There's not a lot of sanding and additional processing, typically such as a lot of mechanical means of processing woods. When engraving woods, different types of wood can produce different contrast and engraving results. Woods have many applications, such as small interior signage, interior decorations, fashions, accessories, promotional gifts. Some of the most common woods out there that we sell, for example, through Trotec, are your walnuts, cherries, oaks, alders, and maples. A good spectrum. And there's a QR code here for these solid, high-grade qualities of woods. Some of the woods that I would recommend staying away from, depending on what you're doing. If you're planning on doing engraving of woods, here in this next chart really does explain that some species can actually cause some problems. And that is in grain pattern. Grain pattern is going to actually give you a pattern in the background of the wood. And you can see here, pine and oak, for example, are going to produce some of the more effective grain, especially if you're doing things like photographs or highly detailed engravings into that wood. That grain can really effectively interfere with the look of the finished product. So if you compare light-colored woods to light-colored woods, here pine and oak versus maple and cherry, you can truly see the difference of that grain really coming through that engraving. And the reason is the species tends to have soft areas, and then it has hard areas, and the density difference is what's going to cause that visible grain. Because the laser is very consistent, the result in the engraving will actually produce an effect like this. So stay away from materials like spruce, oak, bamboo, and pine when wanting to grade materials like photographs. Where stick with cherry, walnut, maple, or birch if you want to do a photograph or high detailed engravings because of that grain pattern. Now, cutting wood is a sublimation process and considered highly desirable. Pre-finished and powder and clear-coated wood is best recommended for cutting or engraving wood, and I will get into what kind of finishes are recommended. Most wood needs to be finished prior to laser processing, and as I said, we will get into that. But when cutting or engraving it, pre-finished, ready-to-go wood, accurate focusing is necessary for the best result. Finding the appropriate laser parameters. Just because one species of wood may work on a laser parameter or power and speed setting, one species may be completely different. So finding the appropriate power parameters. Using the appropriate or suitable optics based on the thickness that you're cutting. Using a cutting table. And then also using a compressed air or air assist for the best cutting quality. I was explaining density earlier. Here's a good example of density. So what I have here is I'm going to cut a simple shape out of a 1-inch square with 120 watts of laser power. So the first video here shows a 1-inch piece of balsa wood, actual time to cut. As you can see, it was less than a second to physically cut. The next one is cherry wood, which is going to be your medium into your hardwoods. And as you can see here with cherry wood, it takes a few seconds to actually cut through the same thickness as balsa wood. Over twice as much time because that density has increased. Now on the last one here is also 1/8 of an inch or 3mm ebony wood, which is one of the most difficult woods to cut on a laser that I have found. And as you can see, you're cutting ebony wood. The power and speed necessary in order to cut that wood took over just around 5 seconds. So the density of wood can make a huge difference in how much processing time. Also, thicker wood, if you don't have enough laser power, you'll find very quickly that the thicker the wood is, the more power you need. So if I was trying to cut, say, through a 1/2 an inch piece of balsa wood, I could easily do that with a 50 watt. Where if I'm trying to cut through a 1/2 of an inch thick of cherry wood, it's probably going to take me 100+ watts to get through that. And a 1/2 an inch piece of balsa wood is not even going to be possible. You're 300 or 400 watts before that would be effective, and then the edge quality may be poor. So density can make a huge difference on cutting. When engraving wood, contrast is everything. The lighter woods are going to give you a lighter contrast, as you can see here. So if I'm engraving something like maple wood into cherry, into walnut, ebony, you can see the density or the contrast based on the brightness of the wood. The lighter the wood quality, like something like maple, you're going to get a better contrast. So that engraving pops out better. The redder, and then as you get into the darker woods, that contrast tends to be reduced as the species gets darker. So keep that in mind. Depending on if it's going to be a signage or a photograph, you want to use the lighter species of woods so that you do get that higher contrast engraving, if that's the effect you want to see. Now, besides standard stock, off-the-shelf, raw woods that are just wood, there's also composite and engineered woods. Engineering woods are basically woods that are combined together with adhesives. These woods are manufactured by a variety of materials. They've contained some woods into lumber. Some of them are used plastic and straw-bound combinations of woods with adhesives. They're sometimes coated with veneers, so they look very, very nice on the surface, but the inside core is made of medium-density fiberboard or particle boards or multiple layers compressed with resins and glues. They tend to be inexpensive because they tend to use the lower quality woods on the inside of these, and it can cause some problems with lasers. The benefits is they're weather resistant when painted and sealed, but they also may contain harmful chemicals. We recommend also using air assist if you are going to process these. Some of them have good benefits, others can actually be problematic. And so we're going to go through a little bit of this because there are more difficulties when using engineered or composite-based woods than there are just real or raw woods or natural woods, if you will. The most common is plywood, MDF, veneered MDF, and then Trotec Eco. Plywood, MDF, and veneered MDF are very similar, where there's multiple layers typically. MDF is basically ground up into a pulp. It's basically thick paper. Veneered MDF is basically thick paper with real veneer on each side, so it looks like it. That's one of my favorite materials to work with because it's incredibly consistent. Plywood is my least favorite composite because the inside cores tend to cause a lot of problems. If you hit a glue pocket or a knot on the inside layers of plywood, you'll find that you'll get inconsistent cutting. Engraving's okay because you're engraving through the top layer on any of these, especially on plywood. MDF does not look as good for engraving because it doesn't give you great contrast, and honestly it doesn't really look like wood because it's made of more of a wood pulp or wood sawdust. Veneered wood is my favorite, like I say, because it still looks like wood, and I'll go through this. And then finally the Trotec Eco, which I will show you in a minute. It's a little bit different, made from a cellulose fiber. Plywood's definitely inconsistent, as I was saying. Plies can interfere with the cutting. Really, really keep an eye on it. Trotec does sell a line of plywood, but the inside plies are all the same. This way you get consistent cutting. So if you buy a plywood made for lasers, then it's going to give you a more consistent result. If you buy plywood at your local hardware store, you're going to see about a 10 to 20% failure rate when you cut materials of just not cutting out because of little pockets that you'll hit. MDF and veneered MDF, like I say, are more my favorite because they're highly durable. They're very consistent when you laser cut it because it is basically thick paper. And then the veneered MDF, which has the veneer on the outside, and then the core is made of MDF core, is ideal because it is guaranteed to be consistent. The wood on the outside still looks like wood. It makes it to where it's more durable. You can see the little flex hinge boxes here made of the veneer MDF. Real MDF doesn't have a lot of contrast. It does engrave, but and it cuts beautifully. It's great for structural type stuff and stuff like that, but usually when it comes to decor stuff, I won't use that. And then plywood, if it is consistent plywood made for laser, it does work very well. It's very strong as long as those internal cores are consistent. Here's a few links if you want to look at some brands that are guaranteed known to work that Trotec sells through our material site. Now, Trocraft Eco is a little bit different. It's kind of like an MDF, but it is made from a pure cellulose fiber, produced without additives, and it's fully biodegradable and emission-free. It's incredibly lightweight and easy to process, ideal for model making, interior design. It's environmentally friendly, and the nice thing is this makes MDF look weak. It's so strong, it really amazes me. And the detail I can cut on this for the thickness is 2 to 3 times that of even something like an MDF. Phenomenal material to work with. Not a great contrast for engraving, as you can see with the little lion here, but it does almost a pleated pattern on the surface, but it is a great material to work with. I do suggest get a sample of it, give it a try. If you really are looking for a strong green style of material that you want to work with and that is truly unique, also incredibly strong, but still an environmental biodegradable fiber, this is the material you may want to work with. You can scan this QR code for more information. Recommended woods. So overall, basically the recommended woods is finished solid wood, MDF woods, veneered faced MDF woods, laser grade plywoods, and then exotic woods. Yeah, walnut, cherry, oak, alder. Oak mainly for cutting. I don't recommend as much for engraving as I showed you with the grain patterns. And then you can basically play with power settings and stuff until you find that the best process setting for that material. The next thing with woods too is the one issue that you will come across is right out of the laser system. Typically the laser finished engraving will look like this. And this is because we are basically burning the material away. And this is why all wood is recommended to have a clear coating of some sort onto the surface of the wood. Recommended woods that have a clear coating, so the wood's already been completely sanded down, it's been finished, and then it's been coated with a lacquer coating, a clear paint of some sort, polyurethane, varnish, or oils. These will actually protect the surface from any of the haze or smoking effect, and then it will give us the best effect. Different type of coatings can be done. Realistically, it doesn't matter what the coating is. Most woods are going to come with like a lacquer or a varnish or polyurethane. Sometimes oil. I don't like oil as much, but it is possible, and it will produce a protected surface. And when you do have a protected surface like this, you can then easily wipe that smoke haze off of the surface of the wood after it has been laser cut and or engraved, simply by using a damp cloth. So you can see here that same little sample here, if I hit play on this video here, as soon as it's out of the laser system, just a damp cloth, just a cloth soaked with water, can be wiped off, and then you have that nice finished, high perceived value at engraving within seconds. There was no time lapse or anything there. It only takes a few seconds to wipe that off. If you do got intricate cutting patterns and you really want to get any residue off, sometimes a staining can get down into that clear coating, and in that case a magic eraser works really well as a good laser hack here. So this has already been cleaned, but you can see here there's some little black spots from the heat of the laser, and so if you take that with a magic eraser, wet the magic eraser down and go over the top of it, you can very quickly take any additional little residues off. And those little smoke hazes that tend or burn marks that kind of get into that clear coating can be taken off additionally with a magic eraser. So between these two tools, you get a very, very clean finished result, higher perceived value, therefore a higher return on investment when selling products that are laser cut wood. Some wood applications, common wood applications, some of the most common is inlay. Nothing beats lasering when inlay, or no other process of inlay is better than with a laser. And to To produce an inlay file with a laser system, it's very simple. Take a vector-based design file and then convert it to a black fill, and that black fill is sent to the laser as an engraving with a red outline to cut it out. Then convert that black to a red outline, then send that file to cut your veneer out. Take the engraved product and then the cut veneer as two separate files, and then glue the pieces inside each other. So a little bit of power and speed settings to make sure you engrave with enough depth to about the thickness of the veneer. This does take some trial and error. And then cut the veneer out, place the veneer into the engraved pocket, glue it down, roll it in, let it dry, and then sand it off, and then you can lacquer it or finish it after that for a perfect inlay. There is no method or technology on this planet that will exceed the quickness and quality of a laser system, because it'll produce that intricate engraved depth pocket as well as cut the veneer or other materials. You don't have to inlay wood veneer. You can inlay mother of pearl. You can inlay plastics. You can inlay gold leaf, whatever you want down into that engraving to get that effect. The laser technology is the king when it comes to doing inlay effectively and fast, better than any other technology on the planet that I have found. Photo engraving is also stunning, high perceived value. This is a 12 by 24 engraving onto the surface of a solid piece of cherry wood. Very, very large engraving, high detail, high perceived value, and an outstanding return on investment. Large engravings can yield thousands of dollars if you have a big enough laser. Large engravings of sceneries and stuff that are put behind fireplaces will typically go for several $1,000s a piece if you got a good image. This is a very profitable application. Also very desirable because it has that natural richness from woods, and that look and feel that works just really well and produces a really nice return on investment. Another one is the flexibility of wood. I really like the flexibility in bending applications. You can cut these little notches, if you will, different styles of notches for different effects. And what it does is it actually produces, there's enough flex within wood that you can wrap it around the corners of different product. You can scan this QR code for information on how this process works, how to do it, as well as design files. These kerf cut or rigid materials can turn into a flexible bending solution. Is a truly outstanding, and again, it's another application that cannot be done realistically or effectively with any other type of technology. Here's a few Flex applications. Before was just the actual Flex files. Here's some project files for you. Some little cubes and boxes and Flex hinge boxes and pen boxes and stuff like that. So as you can see, great material. It does take some time to laser cut depending on your laser wattage, but you can literally turn a piece of rigid sheet stock into a flowing sheet, if you will, if you have enough time. It is a very fascinating application, and again, one of those applications that are laser centric. There's really no other technology that can effectively do this, especially the way a laser can. 3D effect, also very effective because the laser systems can actually generate different shades of grayscale and then apply different power based on their shade and grayscales. It's called relief mode in the Trotec driver. Some laser machines call it 3D mode, but effectively with a gradient graphic, the laser will effectively engrave three-dimensional engravings down inside. This is going to far exceed the detail that can be done on like a CNC machine. It's going to be far, far faster than something like a 3D printer, but it's also going to be done into materials like wood like this. High grain woods like cherries and walnuts and maples and stuff like that are ideal. Stay away from your grainy woods that I showed you earlier. Here's some 3D relief files to get you started, as well as if you want to clip art or make like the front of your building or have a custom 3D setting created. There's a website that sells 3D files. They are kind of expensive, but it does take a lot to generate these. You can do basic 3D design in most design softwares, but if you wanted to do like your face or something like that, it can be more difficult if you don't have a 3D scanner. So many other possibilities as well. Definitely play with it. It is the most common material, and if you're just getting started with lasers, this is the material I suggest to play with. It is the easiest to work, most user-friendly. It's also the most forgiving material. If you don't focus properly or if things are off a little bit, usually wood still, it gives you a lot more tolerance than other materials. So it's one of the greatest materials out there to get started on your laser. High perceived value, good return on investment, and it's a great material to work with. Next up here is laser processing acrylics. Acrylics are an awesome material to work with because acrylic naturally handles heat very well. It can handle the laser power very well. A lot of plastics with lasers don't handle heat as well as the other plastics, and acrylic is one of the best. And so getting into acrylics, it is a great material. It has so many different markets and applications. There's so many different colors and styles of plastic out there, from awards to advertising, architectural, point of purchase, displays, decor, dimensional letters, signage, jewelry, point of purchase, outdoor signage. There's so many different applications. And really it's like the woods. Because there's so many colors and types and looks, and very unique looks, because it is a plastic, but yet it still holds a high perceived value because acrylic is a kind of an expensive look and feel plastic. It's not some of the lower end looking plastic. And so I like it because it does produce that high perceived value and can be produced into so many different types of applications. Advantages of acrylic: it's UV resistant, great for indoor and outdoor application. Unlike a lot of or most other plastics, it can handle outdoor UV. It has excellent optical properties, wide range of colors, textures, finish combinations. You can get mirrored acrylic, you can get glitter acrylic, different frosted effects, neons, thicknesses, and it is just one of those materials, and the sky's the limit. The more time that goes by, it seems like the more variety of acrylic there are to choose from. The one warning I do want to suggest with acrylic is keep a much closer eye on this than, say if you're engraving brick or stone or something like that, it's less of a chance. But acrylic is the number one material for causing damage with the laser system because it is very, very thick, compressed oil, if you will. It is very flammable and can be, when left unattended, it can very well get away from you. So if done properly, it can be a great material to work with, but there are a lot of processes to make sure that this does not happen. So be very, very careful when working with this material so that you don't damage your machine or even your building if left unattended. Now, there are two types of acrylic out there: cast and extruded acrylic. The big difference is how it performs with the laser. Extruded acrylic tends to be a little less expensive. Cast is a little bit more expensive. Basically, cast is acrylic that's been cast into a mold and then it lets it cured. Where extruded is just that. It's like a spaghetti noodle extruded, where it's heated up and it's extruded out of a long slit that actually creates the sheet of material. Because the polymer chains perform differently, we get a different effect in the laser. Extruded is cheaper to produce and it's cheaper to get, but the effect that you're going to get into the material is considerably different. So if you're just cutting, extruded is ideal. If you want to do an engraving and get this kind of frosty white contrast, as you can see, the contrast is much better on a cast acrylic. And here's what I mean. So cast acrylic is going to give us that white frosty effect. And this is going to be ideal for signage, for backlighting, and it just really gives you that good contrast. Where extruded gives us kind of an opaque, transparent, it's just not as nice. And so just understand that if you get extruded acrylic, the engraving quality is going to suffer. Cutting is going to be fine for either one of them, but the difference is really understand the difference between extruded or cast. Different processing techniques. Cutting of it, you want to make sure your laser has the correct wattage for the thickness. So example, 30 watts, not going to cut a half an inch thick. I would say 60 to 80 watts to cut a half of an inch, and up to 120 watts to cut about up to a 3/4 of an inch. I have done up to 3/4 of an inch with an 80 watt, but it becomes so slow at those higher thicknesses, your increase of flames really starts up. So to make it cost effective, I would say about 80 watts for up to a half of an inch for an effective cutting process. Like I say, you can do it thicker if you have that rare case, but it is needing to where you want to have the correct wattage for that. Always cut your acrylic in one pass. It can be cut with multiple passes, but your edge quality is going to suffer. Processing it in one pass, high speed or high power and low speed to get all the way through is going to give you the best possible edge quality. Adjust the focus of the laser and use the proper lens. 2.5 inch lens is typically used mostly for cutting. Make sure to use adequate speed, power, and frequency. High frequency is necessary to produce enough heat. Usually, I recommend 3 to up to 10,000 hertz on frequency or pulse rate to increase the amount of heat. A very good airflow is necessary. Lots of airflow, a good exhaust system to keep that laser system from causing any type of ignition of the acrylic, especially on the thicker materials cutting with lesser wattages. And I got some laser hacks. I will show some of this as well to make sure that you know how to do that. And then use a proper cutting grid or cutting table when processing acrylic or cutting acrylic. The cutting lens is imperative, so making sure a general rule of the thicker the acrylic, the longer the focal length if you want a straighter cut. I like about a 2 to a 2.5 inch lens cut, even all the way up to 3/4 of an inch, and I will focus into the acrylic a little bit. If you don't want to focus into it, you can use a 2.5 to a 4-inch lens, and that way you get a little longer divergence on the lens and a little straighter cut. But as you go to a longer focal lens, the kerf or the beam diameter is larger, so it actually cuts through thinner material because you're cutting through a larger amount or swath or kerf of that material. So it takes more laser power or lower laser speed with longer focal points. I prefer to use a 2 or a 2.5 inch lens, focus into it a little bit, so I get a smaller lens, focus into it a bit, up to 60, 80, even 100 thousandths of an inch depending on the thickness of material, and so I get a decently straight cut. Another thing is remove the acrylic or the paper mask off the top side before cutting. It tends to contain a paraffin or plastic that can cause the flaming and reduce your edge quality. So a lot of times I'll leave it on the back side in case I do get a little flare up or something on the back, but the top side definitely, especially if you're going to engrave it, you need to remove that anyway. One trick to reduce that flare, when you do get a heat on the backside, this is what it looks like before and after you peel the film off. And here's a laser hack, which I already have online. I'm going to show you here next is a simple laser hack that uses paper towels. This works very well to reduce the amount of heat in the laser. So within 3 to 4 layers of paper towel, just put it into the laser and make sure that it's not quite wringed out but decently wet. Place it onto your vector cutting grid. Then place your acrylic onto that. And then go ahead and focus onto the surface of the material, focus into it a little bit, and then go ahead and cut the file out. What this does is the laser system the excess laser system's heat is being absorbed by the wet paper towel on the backside. And it's going to reduce that chance of backside flare up, even underneath the cutting table, so you get a much, much cleaner cut. Also, it's going to keep any reflection points from happening, and it works very, very well in reducing the amount of heat. If you're doing even thicker material, sometimes I'll use a little pin table effect or these little T's, and you can pop these in, and you can cut them out with the laser system, then place some paper towel underneath, and then elevate your acrylic over the surface of them, and then go ahead and cut it out. This is going to reduce even more the chance of any reflection points, especially if you get into thicknesses beyond 1/2 inch. Anything over 20 millimeter or 1/2 inch, up into like 3/4 inch, even a full inch if you haven't high enough laser power. This effectively, what it does is as the beam goes through, it hits that paper towel, and then it bursts any of that excess into steam. And that steam effectively encapsulates any of the polymer fumes that can be ignitable and keeps them from combusting. So this is a great laser hack to produce a much higher effect. If you were to try that thickness on a lower wattage, it's going to turn into a fireball. You're going to immediately have to lift the lid, stop your laser so that you don't cause any damage to the material or the system. It works so effectively. Here's an 80-watt cutting in time lapse, 3/4 inch or 20 millimeters of cut acrylic. This actually took almost 15 minutes to cut out, but as you can see here, sped up, the steam on the backside keeps that laser system from igniting on the backside. This is unheard of cutting this thickness with that low of wattage without a fireball. And using the elevated effect onto something like 3/4 inch acrylic is possible when doing this process. So the great laser hack, and it is very effective when doing this process. And it's so effective, though, that it absorbs so much extra power that it doesn't even cut through the paper towel on the backside, because all that energy is dissipated into steam, and then it just doesn't have enough left over in order to cause any damage or even cut all the way through that paper towel. So great laser hack that works very well. Engraving cast acrylic, is always going to give you a frosty white effect, as I showed you the difference between cast and extruded. Engraving results are achieved when the surface, just slightly on the surface. Less is more. Don't engrave with a lot of power. You want just enough to give you that frosty white, not too much to produce a lot of depth, because it starts to produce almost this snowy white residue, and it won't look as good. So just touch it to give you that effect. The darker the background, the better the contrast, because it's going to be white on clear typically, unless it's a colored acrylic. But just understand, if you're doing like a photograph or something like that, you need to invert that image before you engrave it so that it looks positive once it's engraved. Depth is possible as well. Actually engraving depth into the acrylic by producing a lot of depth, and then after you're done engraving 3 or 4 passes using something like relief mode, I brush that any excess off, and then I will run the laser out of focus by about a half an inch away from the material, and then I'll go over it again, and you can actually glaze the acrylic. It's like a heat glaze. So go over it, back over the engraving area after you've done engraved, or after you've produced the depth with just a out of focus type engraving away from the material, and then you're going to get this opaque, transparent, almost molded looking finished result. And it's a great application for doing that type of three-dimensional effect, especially if you're going to powder coat this or turn it into a mold or something like that that's going to be reproduced. It can be effective for that type of an application. So as you can say, extruded acrylic, if you do have to engrave extruded acrylic, there's a trick here. What I will do is convert the graphic to 30 to 90% grayscale. So you can see here it's the same piece of extruded acrylic. On the right is engraved at 100% black, and as you can see, that transparent, opaque effect. But if you convert the graphic to, it's like you can see here on the left, 70% grayscale, it gives me more refraction of light. It's not quite as clean looking because the halftone effect or dither pattern will put little dots into it, but it will produce more contrast. So it is possible to produce more of a white effect into the surface of acrylic or extruded acrylic if that is something that is necessary. Finally, many different applications, great applications. Play around with this material. It's a great one to work with if you don't work with it already. But just keep very close attention when you're processing acrylic so that you get the best possible results out of your laser system. If you want some more laser hacks, I have lots of them on here, from nesting to pin tables, using dish soap to get the haze away, wet paper towel trick that I showed you earlier, alcohol with acrylic. Don't use alcohol with acrylic because what it does is it'll crack it when cleaning the acrylic. There's another one here, low DPI on acrylic, to give you a much more highly effective. Scan each one of these QR codes for additional laser hacks for processing acrylic to be really knowledgeable on the material. And then finally, if you do want some of the exotic colors, frost, gloss, duo, we have printable acrylic, satins, LED materials that are designed to allow light to transfer through it. Reverse acrylic, it's coated on one side, so you reverse paint it away or engrave it. You can see through it. Great for backlighting or paint filling. Troglass clear material. And Troglass is the Trotec brand of acrylic that is designed to work exceptionally well with lasers. Some brands out there can be tricky, and they may not produce the same effect. So just because it's acrylic doesn't necessarily produce the same effect. We also do mirror, metallic, and glitter as well. So you can scan this QR code if you want to give it a little sample swatch and just try a few different colors to see the difference. Okay, the next is glass. This is a popular material and also tends to have a lot of troubles. So what I recommend when laser processing glass, there's a lot of tips and tricks on this. There's a lot of misconceptions in the industry when processing glass. And so I'm going to go through that and really explain the issues, concerns, positive, negatives when it comes to processing this material. Glass applications are popular applications used for personal engravings, optics, decorations, interiors, awards, drinking glasses, champagne, flutes, mirrors, awards, gift. I mean, it's just one of those materials. It's natural in its form, has a high perceived value, very similar to wood and acrylics. And so it is very desirable in the laser industry. Now, just something to understand is the laser system only superficially etches glass. It doesn't actually produce any depth into the glass. The laser beam heats the glass on the surface and basically produces real fine particles which are removed or refractured and just basically gives you that frosty white effect. No residual blasting agents are required. You don't require anything else. The laser just goes over it and you get the effect. I can do photographs, barcodes. You can see here is a great little sample here from intricate barcoding to photographs can be possible. There's no dust exposure such as a sandblaster or blasting agents resulting in gases or particles when processing with the laser system. So this is a great material to work with, but if you do want to produce depth into the glass, that is typically done with a sand carver, and I will show you there are advantages of using a laser in combination with a sand carver as well, which I will get into. The benefits of lasers. There's no risk of breaking due to non-contact processing. Nothing's touching except the light of the laser. You may get some little bit of fracturing on the surface, but it's not going to damage the glass itself when etching. A great alternative to sandblasting. You don't need any templates. It's required in its comparison to sandblasting. If deep engraving is needed, the laser can create a perfect sandblasting template. No additional consumables such as sand is required. It's also an ease of operation from a single piece to a series production when laser processing. Engraving quality, however, may vary from piece to piece. The one thing I have found with glass in the industry is that glass tends to be kind of inconsistent, different consistent thicknesses. Even if it's something like a nice wine glass and stuff like that, they tend to be inconsistent in their diameters. There's also a misconception in the industry that lower quality glass will produce better quality engraving. That is incorrect. That misconception comes from the sandblasting industry, where that is an actual true statement. For the laser, the lower quality glass will have more issues and defects than high quality glass, causing that glass to fracture and flake and chip. Inconsistencies in size and thickness, in diameters when you're doing glasses can be more troublesome on the lower quality type stuff. So try to keep with the more expensive, high quality glass or crystal products for the best engraving quality of consistent results. I have found that titanium crystal products produce an outstanding laser engraving result. It can handle more deviation. It's just an outstanding. This glass here that you can see next to the wine bottle. The wine bottle is just your traditional wine glass. The bottle has never been opened. You stick it in the laser and engrave it with the bottle. It does pretty good, but the titanium crystal glass next to it is just stunning. It's just one of those great materials to work with. So the better quality glass, the better quality engraving when it comes to lasering. So stay away from the low-grade stuff if you can. If you can't, then, of course, you just tend to have a little bit higher failure rate. There are a lot of different glass engraving, laser engraving methods out there. The first one is bare glass engraving, using no techniques or anything else, or no like extra process, pre and post processing. And that is to just engrave the graphic with a shade of grayscale. This is my favorite method. I came up with this method back in 2002 when working for another laser company, and I published it, and it has been consistent with every brand of laser out there as long as it can produce a dither pattern, producing basically a shade of grayscale on the glass. So a graphic, instead of just leaving it at 100% black, you take your graphic and convert it to a dark shade of grayscale and then send it to the laser using your dither pattern. And here's what I mean by that. So here's an example using the Trotec logo running at 100% black on our Speedy 360 80 watt at 100% power. So this is just engraved as is, as black. And the trouble that you get in this case is when you start rubbing on it, especially low-grade glass, you get the chipping and flaking. In this case, I'm going to take and convert it to 60% grayscale, and I'm going to engrave it again with order dithering, or a halftone pattern. This is going to spread the pulses apart and give me a pattern effect. The drawback is the edges are going to be a little rough because the laser is effectively producing a grayscale. So if I take that and add a black outline around it, I get the best of both worlds. In this case, with the outline, I'm doing 30% grayscale, or 30% black, with a thin black outline of about a half a point line thickness on the outside. So I get that nice sharp edge quality in addition to the halftone effect. And this is caused by heat. The heat of the laser is actually effectively causing that glass to fracture. So at 100% black, the laser's pulsing 100% of the time. At 30% grayscale or 30% black, it's pulsing only 30% of the time, and so it's spreading the laser pulses apart, producing less heat. Less heat, less chipping, less flaking, and no less buildup of damaging heat onto the surface of the glass. And this is why using different shades of grayscale effectively produce a better engraving on your laser system. Another method that I don't personally like, but a lot of people swear by, it does work, is using a damp paper towel. You can see here, you just wet a paper towel down and kind of slather it over to the piece of your glass, and then go ahead and engrave it. What this does is it dampens that heat. So if you do want to engrave it 100% grayscale or 100% black, and you don't want to do grayscale's effects, but you still want to reduce that amount of heat, kind of like the acrylic setting I showed you earlier, this is reducing the amount of heat into the surface of the glass. It is messy. If you're doing large engravings, it can start drying out, and there can be some problems with this. Make sure there's no bubbles or wrinkles in the paper towel, and then also disable air assist so it doesn't blow off your paper towel as it's engraving. But after you're done, you will go ahead and peel it off, or just wipe off the paper towel, and you get a much more consistent result. It dampens and kind of acts like a heat sink, so we get a less effect. I do find that it's not quite as frosty white as the halftone engraving, but it does do a decent effect with that additional step of putting a wet paper towel over the top. If you're wrapping it all the way around a complete cylinder, it can be tricky because a lot of times it doesn't want to stay on, and so that can be tricky. For flat objects and stuff like that, this is a viable application or laser hack. Another one is an alternative to a paper towel is just using a transfer tape, heat transfer tape or paper transfer tape that's basically put on, or masking tape is put on. Again, it's kind of controlling any excess surrounding heat. You do have to wrap it over the top of it, then you have to engrave it, then you have to peel it all off. This is great if you wanted to, say, color fill or rub, or put like spray paint or something to get different contrast in it, so it's already masked after it's done engraving. But it can be tricky to keep any bubbles or wrinkles out of it, and the engraving is not quite as bright again. It tends to dampen the heat because you're removing that additional coating of the tape, but it is possible. The next one is dish soap. Dish soap also acts as a natural heat barrier. So basically just putting raw dish soap onto the surface of the glass before you engrave it kind of dampens that surface, protects the glass itself again from the heat. So ultimately what you're seeing here is all the different effects are trying to control that excess heat and still effectively engrave into the glass without damaging it. So all these do the same things. Some people really like one over the other, and it's really kind of personal preference. So if you want to use dish soap, apply a smooth, thin, even layered dish soap, raw dish soap, no water to it, basically onto the surface of the glass. And then after it's done, engrave right through that dish soap. After it's done engraving, just wash off the excess soap, and you have a nice, clean, finished laser engraved glass. The next is the one I really like is the Blazer Orange Iconics Imaging Laser Tape. This is a specific type of mask that is designed for lasers. And besides using it for sandblasting, especially if you want to do it for sandblasting, you'd put this on, you would laser engrave it. But what I found is even if you don't do sandblasting, it works more like the transfer tape, but it also stretches and flexes. So this stuff works way better than the transfer tape. Gives you a consistent laser engraving. It's very easy to remove, much easier than, say, like a paper transfer tape. And then in addition, if you do want to continue or have a sandblaster or sand carver, you then can take the finished laser engraved sample where it slightly engraves it, and then you can put that extreme relief pattern depth into the surface of the glass. Great material to work with. QR code here if you want to go ahead and order a roll of this stuff and have it on hand. But another great application specifically for doing this process. Of course, the rotary is a great accessory if you want to do cylindrical, conical items, especially glasses, tumblers, rock glasses, wine glasses, cups. tend to be a lot of different type of glass components out there that are cups. And so since it is such a popular material, the rotary is ideal for doing glass. Trotec rotary is nice too because it angles up on the back side there, so you can compensate for those angles which tend to be commonly placed on glasses. So much so that I've been able to get a flat effect on a martini glass. You can actually compensate for that much angle using the Trotec rotary. Okay, that's it on glass. Next, we're going to go into trending applications with high demand and revenue. This is ones I keep a close personal pulse on the industry, on what's popular, what's not, what's trending, what's not trending. And the goal is to portray that information to folks like yourself for making you more profitable. My job is to make you more profitable, whether by applications, by tips, by tricks, by efficiencies, but also giving you hints on what's popular. If you process these materials that I'm going to show you, they tend to be very popular in the industry. A lot of people are looking for them, and the more people that are looking for them, the higher advantage and the higher return on investment. First one here is 3D checker patterns. I recently did a video that I produced on our YouTube channel. It's a new series I do called Deep Dive with Laser Dave, and it'll go through the entire process on exactly how to do this, creating the three-dimensional checker pattern in relief mode, and then engraving it onto the surface of pieces of material. So if you're doing grip patterns on knives and baseball bats and duck calls and gun stocks, or you just want that patterning effect like fish scales, this is a stunning application. And lasers are outstanding for this process. It is a highly trending application, producing these grip patterns. It's one of those applications that have really not deviated. Some applications or trending products tend to come up and then they come and then they go as quick as they came. This is not one. It is continued to grow over the years, and it works very, very well. Scan this QR code if you want to walk through the process, but it is a beautiful application, very highly profitable application, and it can be done effectively and fast with your laser systems. Next one has been popular for almost a decade. I originally thought it was going to be an application that will come and go, but I was wrong. Effectively, this has been one of those applications that has came and it stayed. It has been steady consistently for a decade now. Customers that do this application have found that it is one of the most lucrative that they can do. You can pick up these cups typically from something like JDS for between $4 and $8 depending on the type per piece, and then you can turn around and sell them for $20 to $25 engraved. On a Trotec laser, I can engrave a decent engraving in 2 to 3 minutes. And then if you stack up and run multiple cups at a time, like this QR code, if you scan this QR code, I have a laser hack that'll walk you through how to engrave 3 and 4 at a time on a rotary, making this very effective, producing a tumbler in on average 20 to 30 seconds a piece. And then turning it from $6 to $20, it's very effective. I know of customers that are running container shipments, containers of these cups every month. So it is highly effective, highly profitable application. Places like JDS has come out with so many different types of choices and colors with their different types of looks and feels. You can use name brand ones, but effectively they're the same thing. You're just paying a little bit more for that name brand on it. But some customers will, they'll pick up a Yeti brand, for example, and they'll charge $40-$50 for it, and then they'll engrave it, sell it for $85. So if it's worth it, great. But it is a very, very very popular trending application that does not seem to be going away. Due to the fact the cups are wearing out, people want different images, logos, graphics, their favorite sports team on them. Whatever it is here to stay, and I think that's not anything that's going to go away anytime soon. Another one that's been popular the last few years is laser processed jewelry and engraved jewelry, laser cut jewelry. Just a lot of pop culture type stuff is popular, from engraving, little instruments to beakers to leaves to pop culture, stuff and fun stuff to epoxy resin. It's just been a very popular, especially if you go into something like Etsy and look for laser engraved products, you will see a ton of this. The nice thing about this is it uses very little material. It takes very little time to process. In addition to it doesn't cost much. It's very fast and reuses. The material cost is almost nothing. You're talking minute or two engraving, 10 cents worth of materials. And then, of course, you still have to put the little hatch or the jewelry aspect on it, maybe put it on a back card. And then they're turned around and sold each jewelry set or pendant or earring is sold for $12 to $15. So the return on investment has been stunning. You just want to stick with ones that are popular, items that are popular, but even if it doesn't work, there's not a lot of time and material required to give it a try. Resin has also been very popular, especially on the jewelry as an offshoot of that, as well as other materials, especially as they've come out with a lot of the UV resin. So it's no longer of mixing multiple types of resin or epoxy resin together and mixing it up and then putting it in. You don't have to wait for the curing process. UV resin is ideal. You basically pour it in, you can add pigment to it, and then it's cured within seconds. Here's a QR code on where to get it very inexpensively, the whole kit, the starter kit, and this one is skyrocketing. And I actually have a video of the process here. So if I take this simple little design file, take a black outline, and then convert it to a cut file, and then cut it on this thin piece of bamboo. So now I've got a simple bamboo little jewelry here. In this case, I'm going to just take some UV resin, put 3 drops of red into it, stir it up, pour it into the laser cut. And the nice thing about this stuff, it tends to dome. What I mean by dome is you can get it right up, liquid high over the top, hit it with a flame torch to pop all the bubbles, stick it under a UV light, and in 30 to 40 seconds it's cured, and you've got your finished laser cut and epoxy filled jewelry, multicolors. And that because it cures so fast under ultraviolet light, 30 to 40 seconds or a couple minutes depending on the thickness, you're able to turn and burn these type of products. Larger UV processes or UV chambers may be necessary if you're doing large batches, but it's also very rewarding. It's very fun to do. I'm not really into jewelry as much, but it was really fun to work with the epoxy. Electronics and mobile accessories are something very popular. This is something that's kind of never gone. The difference is what's popular right now. Always has been popular is, of course, any current products, phone backs, phone cases, phone amplifiers, etching your AirPods with a fiber laser, making custom docking stations, flash drives like the fancy aluminum or wood flash drives, anodized aluminum power banks, which intend to engrave really nice, mouse pads. These are always popular. Stay with them. If you can find something that's popular, it is a definite application that produces a good return on investment. Here's a couple applications. They're using the JDS leatherette type material. This is one of their mouse pads. And as you can see, I like to do 2 passes on it for the best effect. You get that really nice high contrast. Here's a power bank. These are great for like schools and stuff like that are doing fundraising. Here's a flash drive that's all made of wood. You can buy these on Amazon, the whole case and everything. Just really gives you that high perceived value look by engraving the entire process. So great application, great material to work with. Also very trendy, very high return on investment. Can almost double the value or the cost of this. So you pay something like $15 for the actual box and the flash drive, and then once it's engraved, you turn around and sell it for $30 with customization on it. Light up has always been popular. Whether you're lighting up resin or any type of product, any type of light up type product has always trended high because people like things that light up for some reason. So this is a material or an application that has always been popular. And then another one that I've come aware of about last year is instead of just doing 1 or 2 items, always go with sets. The entire gift sets and baskets and stuff like that are extremely popular. So instead of engraving a wine glass, engrave 2 wine glasses, some coasters, and the entire bottle with it. And then engrave a box, and you've increased the value, the overall perception of that value greatly. So the knife, the leather holder, the cantina, whatever different products are in there, the more you do, the more products that you can put together as a bundle, the more return on investment you will see. One that has grown over the last few years is the leatherette. JDS has come out with this stuff, and at first it was just a few cups and a few simple things. Then it was sheets, and now it's everything from cigar holders to the product seems to almost change daily. It's because people love it. It has an extremely high perceived value. It's got a very rich, luxurious feel. It looks expensive, it feels expensive, and it lasts really well. So it's got a good durability and wear factor. Great material to work with. If you haven't played with this stuff, everything from pens to cigar holders to coasters, all of the above. And every time I go to the JDS website, more stuff seems to be on their website. So stick with this stuff. It's almost a guarantee as long as the product is popular. All different colors, as you can see, and it just works really well. Commemorative bricks have always been popular. When you're paying for that school or the church or the rec center, a lot of times they will sell bricks for $200 or $300 a brick, and then they'll laser process a person's name on it, and then the majority of that money goes towards the cost of the building or whatever the project might be. Laser engraved bricks are incredibly popular. If you are interested in processing bricks, the right type of bricks are necessary to get that nice glass edge looking graphic. Laser Sketch is the one I recommend. If not them, you want to use a clay-based brick, but a very popular application if you have that need in your community for this type of an application. And then finally, the print and cut applications. Print and cut applications are great materials to work with. Job control, working with print using a camera system, has been becoming more and more popular. Because printing technology costs have gone way down, what's happened is the ability to UV print on acrylics and woods and plastics and any combustible material that can be printed on can then be laser cut. And if you combine registration points outside of that print area, you have the ability to accurately cut. The camera registration will find the registration point and give you a perfect cut every time. And the laser system will compensate for size, scale, skew, and rotation of that graphic. And so this gives you the ability to do point-of-purchase displays, keychains, products, decor, signage, and it is great. And then you can add that pop of imagery, color. I mean, you can literally take a photograph of yourself, print it onto a sheet of acrylic, outline it in a drawing program, print it out, and then laser cut it to produce a statue. So it is a great application. If you don't have a camera registration, you can still do simple cutouts like puzzles just by giving yourself a little bleed. But this is an incredibly profitable application. It does require having resources like a UV printer, or at least outsourcing your finished laser or your printing to somebody that does have the printer. Printers can be expensive, and if you're not doing it a lot, I do recommend outsourcing it unless you're doing it a high enough volume to keep that printer busy. But you could scan this QR code for a process on even using sublimation to actually do your sublimation printing rather than using the UV printing technology. So great application, high perceived value, high profit margin, high return on investment, and a great application for producing a quick return. The next, I have a couple more laser hacks here. These laser hacks are kind of a nice add-on. I constantly have laser hacks. In previous years, I've done laser hacks 1.0, 2.0, and 3.0. But anymore, I just don't have enough actual little hacks to keep doing entire courses on them because there's only so many laser hacks out there. So I will continue to add them a few at a time to these seminars. This one is using HDR imageries for engraving photographs. So many people want to engrave photographs and they want to know the secrets of the pros. And my secret is when I'm engraving a photograph, I traditionally look for an HDR image. And you may ask, what's an HDR image? What's the difference between an actual photograph? There's two real different types of photos out there, your standard dynamic range and your high dynamic range. A high dynamic range is a dynamic range more elevated than the standard dynamic range, basically. And because the way that it's exposed and the way that it's created in the cameras produces a much better effect on the laser. And I'm going to show you exactly what an HDR image. It's not, in the past, you take a photo, you push the button, it clicks once, and you got your photograph. An HDR image is a little different. Your photo or camera or your camera system will actually take multiple photos, 3 to 5 or even more in some cases, of the same image very, very rapidly. So when you push that button, it's not taking one photo. In this case, it's taking 5 photos. It's taking them at different exposure levels. So it's exposing it, taking one, changing the exposure level, taking another, and another, and another. And then it's combining the best attributes of all those photos together to give you the absolute best possible photo. And in this case, you can literally see in the dark. So we're able to take, and the software right on board the camera these days, heck, most mobile phones will do this in HDR mode, and it will create a much, much cleaner image. And this effectively seeing in the dark. And the benefit of this is that the engraver, when you laser engrave this photograph, it no longer has those really white or bright white spots or the really dark areas. Lasers don't like that. It likes a middle tone range. HDR produces a beautiful middle tone range. So that when you engrave that graphic, here's an HDR image, there's no real black areas, there's no real dark areas, and there's no real white areas. So when you engrave that digital image, you get a much better finished engraving contrast. So that is my laser hack when you're looking at a photograph or if you're taking the photograph. And you can also look on our the Trotec USA YouTube channel. I have an entire application training seminar on engraving photographs. And you can watch that and go through all the details, lenses, and all the details of materials and stuff like that on engraving photographs. But one that I didn't really discuss on as for more of a laser hack is to use HDR photography for the best possible output of graphics. And so this is a great one. It doesn't matter what engraving material stock. Well, it does. If you're engraving on bad stock, it's not going to look as good. But, good quality engraving material. But it doesn't matter. With the good photograph, HDR photo is going to always produce a better engraving. Next is laser cut compression joints. This is one I've used for years, but I've just recently converted into a laser hack. And you may ask, what's a laser cut compression joint? Well, when you're making tabs, and I've got an actual video of the process. When I want to elevate something or put a box together, sometimes they don't like to stay together. If the little tabs or components or dovetails or whatever you want to call them don't stick together, how do you get that to do it? So in this case, I'm going to take this guitar and I want to make a stand for it. And so to do that, I'll make a little stand that I want to cut out with the laser, and I'll draw a rectangle, the thickness of the wood. So I'm going to put in the thickness of the wood after I measure it, take a pair of calipers and measure it, in this case 1.3 inches. And then I want to put that into the center of my piece of, or my circle here, because that's where it's going to stand on. And then I'm going to snap it to the bottom of the guitar here, hold shift, select the outline of the guitar, and then weld that together. So in Active, I've made a little tab that drops down into that thickness. Now the difference, if I were to cut that out, it would work okay. But if I want it to really sit in there, what I'm going to do is I'm going to put a compression joint in. So I'm going to use the line tool, and I'm going to draw a little line. I'm going to add a small or teeny little tiny circle on the top. And then I'm going to duplicate that using Control D and Corel Draw. And I'm going to add another one. And then I'm going to go ahead and save that. And we're going to open up that file in my Ruby software and then send it to the laser and cut it out onto the material. In this case, I'm using acrylic, which is especially hard to compress things together. Wood is very easy. It's very forgiving. Acrylic is not. So if you ever want to connect things together in acrylic, you're going to find it's very difficult. So in this case, what I've done is I went ahead and engraved the guitar and I cut out the little circle that I just designed so that I have one piece into the other. And now, because of those little compression joints right there, when I press this into the cut area, it's going to slide in and it's going to very, very effectively kind of hold itself into place. If I don't do that, and here's an example of the one before I did that, I go ahead and do the same thing. Nothing's different between these two files. The only difference is I didn't put the compression joints in. When I go to pick it up, it comes right out. It likes to wobble around in there. It doesn't have those little tabs to kind of keep it from compression. Here's a cube where I did it. It also just produces a much nicer effect, kind of compresses all those together and gives you that finished result onto the surface of the material. This works on woods, it works on plastics. I really like it for acrylic. Just a simple little line offset and just kind of gives you that expansion impression onto the material and then allows it to go together and hold itself together. No glue is required. It really works well and it's a great application. Here is a design files. If you want to make, I've got a couple cubes on there. I as well got this little guitar just to kind of see what the design files work or how they look. And so you can try to reproduce those if you'd like. Material thickness still needs to be right. You still want to get the right power settings. Sometimes I will even cut the little hole opening a little smaller so that it compresses in a little bit tighter. So the opening that I cut out of that little circle on the guitar there, make it a little narrower so that it can compensate even and make it a little tighter. tighter. Kind of squeezes those little tabs in a bit more and gives me even a tighter fit. But it depending on, of course, your power settings and cut settings, it may be necessary to make it a bit smaller to compensate also the laser beam you're using. But in this case, I did nothing. All I did is put the tabs in, and you saw the before with the tabs and without, and how much more effective they go together, and they stay together. So great application tip. Go ahead and give it a try. You can scan this QR code and download the compression joint files that I have created to get you started. Well, that's it for this seminar. Thank you so much for listening or watching, and let us know if you have any questions. You can go to our website, contact any one of our 12 locations across the country, and thank you so much for watching, and until next time, we'll see you